Welcome to part 3 of Competency 1. In this video, we will work with scientific notation. Okay, you see our diagram explaining scientific notation. We have a given value. Either it's going to be a whole integer value or it'll be in a decimal format. Now, to put those into scientific notation, we have to have a coefficient. And this value always has a whole number before our decimal, and then it could have a number of different values in each digit place, okay? But it's always the same format. And then we have it multiplied to a base 10, okay? The key is finding out the exponent, okay? Make note of when we have a positive exponent and when do we have a negative exponent. Now, be careful with this because it isn't just cut and dry. Oh, I'm always gonna, if I have a whole number, I'll have a positive exponent. Oh, if I have a decimal, I'm gonna have a negative. That's not necessarily true. Okay, so let's look at number 1 and number 2. Well, let's just keep it here at number 1 so we can see our diagram to start. Okay, number 1, which one of the following is a scientific notation for negative 125,000? Okay, first off, the negative stands. Scientific notation has nothing to do with anything about changing the negative. If it's negative, it's just going to be negative. So that helps us eliminate two options. Just because we have a negative exponent doesn't change the whole value of things being negative. That's not what exponents and negatives do. Okay, that being said, I see an excellent setup for our coefficient. So what we need is a decimal right after the 1. Okay, and you'll see forming right here, this where I highlighted, that's our x or our coefficient that we need. Great. So A and C have everything set up right, but then we have to make that ultimate decision for our exponent. Okay, right? So what we need to look at is look at our diagram. So we need the non decimal or here. See, I'm highlighting it. That's what we're looking at. That integer value. It's a whole integer value. Okay. So we're going from the integer to the exponent. So I see a positive exponent. Ah, well, what is the exponent? It's positive. You said all that. Okay, just count. What do I mean by count? Count each space that you had to move to get into that form. Okay, so I have my decimal there. Well, that's 1, 2, 3, 4, 5. So my exponent must be a 5. Whether it's positive or negative, regardless, we must have a 5. Well, you see A and C have 5. Okay, so that's all right. But I'm thinking it's going to be option C. That's what our diagram shows us. But you know what? You know how we can check? Put it in the calculator and see what happens, okay? All right, so let's do that. Negative 1.25. Now, we do have a button right here, very convenient. It says, you see a little multiplication X there, little cross, and then 10 to the n right there. Push that, it sets it up, enter what you need. Well, we need to enter a 5, okay? And then enter again. That gives us the value that we were given. So we know that option C is correct. All right, now let's take a look here at number 2. Which one of the following is a scientific notation for this decimal form, very close to what we had before? 0.000125. Okay, fine. What do we need? We need the same, well, not quite the same setup we had. Use this because it's positive. We have a positive coefficient. Well, all of our options are positive, so that's good. And then we know we need 1.25 as our coefficient. Well, they all have that. So all of them have the beginning set up correct. However, A and D are incorrect. Scientific notation requires a base of 10. So A and D just simply are wrong. Okay. So they're one of them's base 5, the other one's base 4. All right, so B and C, here we are. Well, looks like we got a good situation because we have different coefficient. I mean, excuse me, not coefficients, exponent values. So one's 4 and one's a 5. So regardless if it's a positive or negative, let's go count. Okay. So let's see. From the decimal point position of given to what we need, we have 1, 2, 3, 4. So it has to be 4. So I'm thinking we need option B. But let's put it in the calculator and verify that. 1.25, push our button that we need, and say -4. All right, push enter, and that gives us precisely what we had given. So we verified that that is correct. Okay. All right. Let's move on to number 3. Number 3, which of the following is a scientific notation for 0.0329? Okay, as we know from scientific notation, we need to have a decimal after the 3. So our coefficient needs to be 3.29. Well, let's look at our ABCD options. Well, that eliminates C and D. Okay, now we need to determine the spaces, the digit spaces between where we need our decimal and where it is at the as the given. So that's 1, 2. So we know that our exponent needs to be two spaces, but is it going to be a -2 or a +2? Well, let's take a look at A and see what happens, okay? So 3.29 in our calculator. Now push our scientific notation button right here, and there you go. Well, let's try A first, okay? -2. And that is exactly the given, okay? And how I kind of know this is that I look at what I need and which direction do I have to move from what I need to where the value is, okay? But that's when you're when you are trying to change to scientific notation. Either way, doesn't matter. What you can do is simply put it in the calculator and try it out and see what happens. And that's what we did and we verified. Okay, let's look at number 4. Which of the following is the scientific notation for 631? Well, we know we need the decimal there. That's where we need it. But it was over here. There is an understood decimal that is lingering behind all whole numbers. We just don't need it, okay? Unless it's money. Then we use that. When it's money, that's when we have the 2 zeros to show those values. Okay. That being said, well, to get from what we need to where the given is, that is 2-digit spaces. That's 2 spaces. But it's going the other direction from the one above. So I'm saying instead of a 2 exponent, we need a positive 2 exponent. Well, let's start eliminating some things. Well, obviously, C and D, again, are not what we want. That coefficient is incorrect. Now, we'll try B this time, okay, because it has the positive 10 to the positive 2. All right, so let's give it a try. Let's see, 6.31. Push that magic button we have and push the 2 for our exponent and enter. And there you go, verify. It was option B, okay? All right, now let's move this up and we can take a look at 5. Okay, which of the following is a scientific notation for 4 over 3? Okay, what do? We put our fraction in and 4 over 3. Now, what we're doing, we've typed it in, we push enter to enter it, but now we have to push toggle to reveal the decimal. Okay, now that is a repeating decimal, so that means that that fraction equals 1.3 repeating. Okay, all right, that being said, let's eliminate some things. Okay, well, A doesn't work because we don't have the repeating. And this infinity, come on, that doesn't make sense. Okay, maybe it does in some other realm, but not this one. Okay, so let's get rid of that. Now, B doesn't work because that coefficient has an improper decimal placement. Now we're down to C and D. Okay, wait a second. Notice that the value we have here, the given, equals the coefficient. Well, that means that you don't multiply it times anything. Well, anything? It's okay as is. Okay, now I'm looking at my options. Well, if you remember what 10 to the 1 equals, well, that's going to be like just multiplying times 10. Well, that would change our given, and we can't change our given. So let's look at D. 10 to the 0 power is 1. And if we multiply this by 1, we won't change the given. Okay, so what I'm saying is that what we want is option D because it's multiplying it times 1. Okay, well, just to verify that, let's look at C. Okay, all right, so in order to keep a true form, I'm going to put in the given form. So, or I could have just used, actually, well, I'll do it all. Okay, 4 over the 3, a- arrow over. Now, your magic button here, and let's put in the 1. That's what it changes it to. And to be honest with you, we just marked out that coefficient. Okay, so I'm not buying any of that. Okay, that's just completely wrong. And now we can test option D. So let's see, 4 over the 3, arrow over, push our scientific notation button, and put 0 in as your coefficient. Push enter, and we go back to the given, which is what we wanted, and there is the value that we're looking for, okay? So option D has been verified. And I'll get rid of some of this clutter, okay? All right, let's look at number 6. Which of the following is the value of 0.3 repeating, which is 1/3, by the way? If you haven't figured that out already or you don't know, that is 1 over 3. Okay, so which is 3 repeating times 10 to the 3rd power. Okay, well, what we do is we put in our given into the calculator and see what comes out. Okay, so we don't have a way to put in repeating in our calculator. Well, we could put in 0.3 and just keep pushing threes for a long time. Or we can use its equivalency that I have written down here. 1 over 3, arrow over, push your button for scientific, and then 3, exponent, push enter. Okay, I don't see a given item or given option that looks like that fraction, but push your toggle. Lo and behold, option C mimics it exactly. Now, please be aware that A terminates, it does not repeat. That's not the same thing. So, obviously, that needs to be marked out. But easy to confuse, but just not the same thing. D is this coefficient equivalent that we had to use. So, that's not a large enough number. And then B, well, if we arrow, no, I don't even have to. Yeah, see, I did arrow up. I highlighted it. See, they're missing a 0. It's not equivalent, so that won't work either. Okay. All right, this is the last video. I'm sorry, not last video. Getting ahead of myself. This is the last question in this video. And I wanted to thank everyone again for watching and liking and sharing us. Happy testing, everyone.